Hi there, this is Joe Pantaleon here and welcome to my YouTube channel. And this video, we will be discussing about exact differential equations. So sit down and learn. So now, given the functions of differential equation, we have first to establish that the equation has x1 m to the functions of x and y, which was derived by x plus n to the function of x and y, which was derived by y, which is equals to 0. It is said to be exact if we differentiate that. We have a differential equation of m. Since we derived already this one as dx, so we have to derive this one as dy is equal to dn. And since we already derived this as dy, we have to derive it again to dx. So if it is exact, then the said equation is an exact differential equation. So there exists the function f to the function of x and y is equals to c as the solution to this equation. So in this example, we first test that it is exact. So this is your m where dx is attached. This one, as you notice, is both composed of y and x to the functions of y and x, or x and y. And this one is your n, which is also a function of x and y, which was derived from dy. So therefore, the solution to that is that you have to test first for exactness. So dm to dy must be equal to dn dx. So in this case, dm dy is equals to 2 uh, 2y, I think. Okay. Since there is no, or your y function in here is have the equivalent of 1, and we derive that, so it is equals to 0. Let's see if it is equals to on the other side. So when we differentiate this in terms of dx, so we have first in here, so we have 2y, and this one is 0. So therefore, we have an exact differential equation. So therefore, the solution of that is that we have to find the function of each side. Okay. So first we integrate the m to the function of x, y, dx. So your m is integral of y squared minus 2x dx. Okay. So that will be x y squared minus x squared. The flip side, we have your integral of n to the function of x and y dy. So we integrate that xy plus 1 dy. So integrating it to the function of y. So we have your x y squared plus y. Okay, and we believe that it is there is a function combining both. So we have a function of x and y, as we discuss it later, is equals to c. So therefore, you just copy with the same variables or the same form. So the first thing is that you have to copy the x y squared, and the rest is that you have to fill it down here. So we have x squared is 1 plus y is equals to c. So that is your equation for example 1. And so we have another example. The x times 1 minus sine y dy is equals to cosine x minus cosine y minus y x. So first we have to establish this as an m, okay, standard equation, m to the function of x and y dx plus n function of x and y dy equal to 0. So this makes the equation transposing. This makes the equation sine x minus cosine y minus y x. Then also transpose that. Okay? So rearranging, then we have say plus sine y x sine y. I have to distribute the x. Okay? X sine y minus x. Okay? dy is equals to 0. So first thing we have to do, so we have to establish that the m function of x and y dy is equal to the dn, the function of x and y dx. So here we have m here, since this one has dx, and n here, since this one has dy. So therefore, dm for dy is equals to the value of y here in cosine x is 1, and we derive that, it becomes uh, 0. And also, when we uh, when we differentiate cosine y, this becomes negative sine. Negative plus negative is equals to sine y. Then we have negative 1. On the other hand, we have n over dy is equals to, no, I mean, sorry, dn dx, I mean, okay, erase that, and this one is x. So x is equals to 1, the derivative of x is equals to 1, so we have sine x, or sine y, I mean, and this one is 1. So therefore, this is exact. Okay, those we find the function as first we find to integrate m to the function of x. So that is integral of cosine x minus cosine y minus y x is just equals to the integral of cosine to the function of x. We have sine x. Also, this one is negative x cosine y minus x y. Okay. The flip side, we then integrate n xy dy. We have uh, that x sine y minus x dy. So this becomes, okay, we call this a integral of sine. So sine y has negative x cosine y And also the integral of x to the dy is negative x y. So as we can see, we have a common thing here, and so we just copy that. So function of x, your solution to that is equals to c is equal to, just copy sine x minus x cosine y minus x y. This is your final solution. So I hope you learned a lot, and thank you for listening.